Hey everyone, my name is Nathan Thwaites, and this is my lab 4 for Physics 2211. The purpose of our lab is that we are trying to estimate the rotational kinetic energy in the system for the experiment. However, because we only need the tracker data to estimate kinetic energy translational in the system, we can just use the point mass located at the center of mass to estimate instantaneous final velocity and by extension the final kinetic energy at the bottom. We did so by incorporating these concepts with a real-life rolling object and rolling it along a downward sloping surface. We used formulas and calculations to justify our answers. The physics principles involved in this lab that are fundamental are the translational kinetic energy, the potential gravitational energy, and energy principle, the kinetic rotational energy, moment of inertia, specifically the moment of inertia of a solid cylinder, 1/2 mr squared, and then one that isn't on here is also the total kinetic energy, which is just the translational kinetic energy plus the relative kinetic energy. So finding the energy, we use the same formulas from the last slide, along with the data here, using the instantaneous velocity as our final velocity of the last 2 points at the bottom for our marker. And before I even go into that, this is the video that we use to get the data for our marker, as you can see.
Okay, yeah.
And we use tracker to plant those points. And then with a little bit of math and using the formulas for gravitational potential energy and K trans, we get K rotational is equal to 0.0352. And then finding the energy mathematically based to compare our answer in part 1, we found that the V velocity is actually different, and it is approximately 2.55 meters per second, which is different from what we had in our original for the velocity. And then our K total is 0.02 joules, which again is different from what we had originally calculated. Potential errors. This is only a simulation, or in this case, a calculation based. The calculations were done by hand and they may be prone to potential mathematical errors. Another potential error is accuracy. The initial velocity, the x and y, were determined through multiple trial and error procedures, and they could possibly be wrong, and maybe even more precise. And what does this mean? Well, our approximation for the final velocity of the object from the observed data is most likely incorrect. Thank you.